this is the simplest form of concrete which are made by only by mixing basic ingredients. These types of concrete are mainly used in the construction of the pavements and the buildings, especially in areas where there is requirement for low tensile strength. So it is also used as a bed concrete below the footings, walls, and seal concrete below the window and ventilator. So it means that it is the combination of ordinary concrete with the reinforcement to increase its compressive and tensile strength to a great extent. Concrete is a versatile material for modern construction which is prepared by mixing together well-proportioned quantities of cement, sand, crushed rock or gravel, and water. Next, for the general requirements is the space specification and code. The standard specifications and codes are very important, especially to the construction process, because it provides clear instructions to the intent, performance, and construction of the project. So such specifications and codes are controlled by the building code requirements, so it can reference the quality and standards which should be applied, and materials and manufacturers' products can be clearly defined. Another one is coordination. So coordination, it is where the concrete work shall be coordinated with the work of other trades to allow reasonable time to set sleeves, inserts, and other accessories which must be in perfect position before concrete bases and pads of mechanical equipment shall be placed to comply with approved shop drawings for the equipment. Workmanship is where the contractor shall be responsible for any additional cost which may result from concrete surfaces which are not finished to the required profile or elevation. And the last one is samples, where the contractor shall submit samples of cement and aggregates proposed for use in the concrete work for approval, enumerating names, sources, and description of materials. So, Portland cement is the most common type of cement in general use around the world, used as a basic ingredient of concrete, mortar, stucco, and most non-specialty grout. Several types of Portland cement are available, with the most common being called ordinary Portland cement, or the OPC, which is gray in color, but white Portland cement is also available. So the low cost and widespread availability of the limestone, shales, and other naturally occurring materials used in Portland cement make it one of the lowest cost materials widely used over the last century throughout the world. And concrete produced from Portland cement is one of the most versatile construction materials available in the world. So, the difference between coarse aggregates and fine aggregates is that coarse aggregates are larger size filler materials in construction, while fine aggregates are small size filler materials in construction. Now, the major sources of coarse aggregates are dolomite aggregates, crushed gravel or stone, and natural disintegration of rock, while fine aggregates major sources are from the river sand or machine sand, crushed stone sand, and crushed gravel sand. So in coarse aggregates, it acts as an inert filler material for concrete, while in fine aggregate, the voids between the coarse aggregate are filled up by fine aggregates. Let's go to the unit of measure. So, unit of measure is an adoption of the metric measure, also known as System International or SI. Concrete components such as cement, aggregates, and water are measured in terms of pounds, cubic foot, and gallons per bag respectively. So today, instead of the traditional measuring wooden box, the empty plastic bag of cement is popularly used to measure the volume of sand and gravel for convenience in handling aggregates during mixing operations. So the measurement will be changed to 30 by 30 by 30 centimeters. So as shown in table 1:1. So in table 1, which is the conversion from inches to meter. So as what you can see in the image on the screen. So it is a conversion of measurement from inches to meter. So you could also compute it by multiplying the length by the conversion ratio. So the length in meters is equal to inches multiplied by 0.0254, which is the conversion ratio of 1 inch to meter. You could also see that there is an approximate value where it is just the value close to the accurate value. In the conversion of units, so it could be done by multiplication or by division process. So in here, you'll divide 8 by 0.10 meters, which is the approximate value of 4 inches. So it is equals to 80 by inspection and analysis. But in the second one, the second formula, 8 is divided by 0.1016 meters, which is the accurate value. Then it is equals to 78.7 by long process of division or by aid of a calculator. You could see the difference of their value. So to memorize the values given in table 1, which is the conversion from inches to meter, it could take too much time and not a practical approach in estimating. So a simple guide will be adopted so that one could easily determine the equivalent values from English to metric or vice versa. So, proportioning concrete mixture is done in 2 different ways, which is by weight or by volume method. The most common and convenient way is by the volume method, using the empty plastic bag of cement or by a measuring box of sand and gravel as explained lately by the unit of measure. We can use these dimensions in a box when using volume method. Common kilograms in a bag of cement is 40 kilograms. So a box with 0.30 meters on all sides can be used since it could be equal to 1 cubic foot. In actual construction work, there are several factors that might affect the accuracy of the estimate, which needs considerations. So these are, first is the inaccurate volume of delivered aggregate by the supplier is very common. So the delivery truck should be measured to check if the volume of aggregates being delivered is exactly as ordered. So this is common when during the construction work, there might be times where laborers fails to observe the right measuring of aggregates being delivered to the mixer. So the quantity of such construction materials must always be checked. Fourth, the use of ordinary gravel, not the crushed stone, needs screening to conform with the specifications. Considerably, the screening processes reduces the usable volume of the coarse aggregates or gravel. Because screening of gravel is necessary, and this means that some of the fine aggregates or sand will be sifted out. It would be sized accurately, and these rocks are usually a pretty uniform size because they've been washed to remove the fines. The water content shall not exceed 28 liters per 40 kilograms per bag cement, and the slump test shall not exceed 10 centimeters. And as what we have observed on the video given last time in our class, we could also use a minimum of 20 liters per 40 kilograms of bag cement when we use the ratio 1:2:3:0.5, wherein 0.5 is the proportion of water that can be computed by multiplying 0.5 and 40, which indicates the kilograms.
Next, we have the concrete tests. First is the testing laboratory. It is na responsible na han contractor na mag-employ hin compression tests and slump test and submit 5 copies to the engineer and architects. Compression slump tests. It is to check the concrete if it is strong enough to hold forces. Compression tests. Make 3 standard 15 cm by 30 cm cylinder and test in accordance with ASTM C31 and C39. So for the slump test, for each representative of quantity of concrete mentioned above, 2 slump tests shall be made in accordance with ASTM C143, 6 days. We have mixing of concretes. First, we have the site mixed concrete, where the materials were mixed with accordance to the manufacturer's recommendation. Ready mixed concrete. In pouring, concrete should not be started until matapos na ang paglaid reinforcement in the whole area on the whole form, and dapat na clean na and inspect na and na-approve na and forms before pouring all the concrete mixture. So next, we have the handling and placing concrete. Third, dumping concrete into carts or bogies with a free fall of more than 1 meter will not be permitted. So dapat dili po sa para dili makarag ang atong concrete mixture. After the initial set of the concrete, the form shall not be jarred, or no strain shall be placed in the ends of the project when forms in the place. Curing and protection. So, bisan natanggal na ang form sa naton concrete, we still have to cover it until nga hard na hiya. Membrane curing compound shall not be used where floor hardener membrane, waterproofing, damp proofing, resilient floor tile, or other floor or wall covering set in adhesive, concrete fill or setting beds, paint, plaster, or other applied finishing or surface treatment are to be subsequently applied. So in the curing and protection, wet burlap is often required so para diri mag-dust an aton concrete para madala niya moist until na mag or concrete forms shall conform to the shape, lines, and dimensions shown in the drawing. So, dapat ang ginhimo nga forms mag-reflect dito han plan or han drawing. Dapat sakto lang iya pagka tied or tied properly hiya para diri mag distort an aton form or an aton concrete nga once mag hard na hiya. Shall be submitted for approval before fabrication and direction of form. So, before magbutanghan form, dapat i-check ana iton hiya kung sakto nan kahimo, kung properly tied ba hiya, or bangin diri asya ang form nga gin-follow. So, we have it to be approved. Dapat aton gihapig ko consider and reinforcement kay once we will put something inside niya, would lead to chemical attack. So, an aton structure or an aton concrete is mawi-weaken. Once we remove the forms, it signifies nga pwede na hiya maagian or pwede na hiya magamit. It shall be so designed as to leave no metal closer than 19 mm to the surface of the concrete or to leave a hole greater than 20 mm in diameter on the face of the concrete. In finishing of slab, finished floor and roof slabs shall be level plain surface unless otherwise specified on the drawings with a tolerance of 3 mm in 3 meters. So we have to follow what is on the floor plan. So for watertight concrete, all waterproofing on deck or wherever called for in plan shall be guaranteed to be absolutely waterproofed and free from leaking for a period of at least 2 years. So, before kita mag-pour naton slabs or naton concrete, dapat na place na an naton pipes para dito na hiya dire na kita gugubapahan aton slab naton concrete para magputhan pipe. So, dapat before kita mag-concrete, dapat nabutang na aton mga pipes. So, concrete floor shall be laid in the alternate strips about 1 meter in width by 6 meters minimum length, but following pattern shown on drawing.
Now let's go to the solving for estimates. So first example is for concrete slab. So in the illustration, you'll see that it is a proposed concrete pavement that has a general dimensions of 4 inches thick, 3 meters wide, and 5 meters long. Considering the slab to be resting on the ground fill, determine the number of cement in bag, sand, and gravel required using Class C mixture. So, solution is first, we will determine the volume of the proposed concrete pavement. So we'll convert its thickness, which is 4 inches, into meters. So we'll apply the conversion of units discussed lately. If you could remember, the approximate value of 1 inch to meter is 0.025. So we'll multiply 4 inches to 0.025, which is equals to 0.1 meter. And in finding the volume, we will multiply 0.1 meter by the width 3 meter and with the length 5 meter. So the volume of the proposed concrete pavement is 1.5 cubic meters. number 2, next is we'll refer to the table 1 to 2, which is the concrete proportion using 40 kg cement and Class C mixture. In cement, we'll multiply the volume 1.5 cubic meters to 6, which is equal to 9 bags. In sand, multiply 1.5 by 0.50, that is equal to 0.75 cubic meters. And in gravel, multiply 1.5 by 1, which is equal to 1.5 cubic meters. So let's have another example for concrete slab. So in illustration 1, 2, a barangay road 4 meter wide and 1 kilometer long after the base preparation requires concrete beam. Find the number of bags cement, sand, and gravel in cubic meters required using Class A concrete if the slab is 15 centimeters thick. So in solution, first, we'll determine the volume of the concrete road. The thickness of the slab, that is 15 centimeters, and the length, which is 1 kilometers, must be converted into meters, and that is equal to 0.15 meters and 1,000 meters. So we'll multiply 0.15 meters by the width 4 meters and the length 1,000 meters, which is equal to the volume of 600 cubic meters. Second, let's refer again to table 1 to 2 using 40 kilograms per bag. In cement, multiply 600 cubic meters by 9, which is equal to 5,400 bags. In sand, multiply 600 cubic meters by 0.50 cubic centimeters, that is equals to 300 cubic meters. And in gravel, multiply 600 cubic meters by 1 cubic meter, that is equal to 600 cubic meters. So the third one, if no 40 kg cement is available, a 50 kg per bag requires 7 kg for cement, 0.5 cubic centimeters for sand, and 1 cubic centimeters for gravel. So in cement, 600 multiplied by 7 is equal to 4,200 bags. In gravel and sand, it is still the same as computed above, where in sand 600 multiplied by 0.5 cubic meters is 300 cubic meters, and in gravel 600 multiplied by 1 cubic meter is still 600 cubic meters. So another example, adopting the problem of illustration 1 to 1 and 1 to 2, we will now try to use the table 3, which is the quantity of cement, sand, and gravel for slab and walls per square meter area. So let's recall the first problem. It is a pavement with a general dimension of 4 inches thick, 3 meters wide, and 5 meter long. So number 1, so for the pavement area, multiply 3 meter by 5 meter. So that is equals to 15 square meters. And in number 2, referring to table 1 to 3, if the thickness is 10 centimeter under Class C, 40 kilogram cement, we'll multiply first for cement, where the area 15 square meters is multiplied by 0.6, that is equal to 9 bags. So in sand, 15 square meters multiplied by 0.50 is equal to 0.75 cubic meters. And in gravel, 15 square meters multiplied by 0.1 is equal to 1.5 cubic meters. And in illustration 1 to 2, the given problem is a road with 4 meter wide, 1 kilometer long, and or 1000 meter, and 15 centimeters thick or 0.15 meters. So number 1, to find the area of the concrete barangay road, which is 4 meter multiplied by 1000 meter, is equals to 4000 square meters. Number 2, if the thickness is 15 centimeters class A using 40 kilogram cement referred from table 1 to 3, then we'll multiply first the cement, which is 4000 square meters, multiplied by 1.35, which is equal to 5,400 bags. For sand, 4,000 square meters multiplied by 0.075 is equal to 300 cubic meters. And in gravel, 4,000 square meters multiplied by 0.150 is equal to 600 cubic meters. Another example problem is for rectangular column. So, in illustration 1 to 7, a series of 8 concrete columns with cross-sectional dimension 40 by 60 centimeters is supporting a girder, each having a clear height of 5 meters. Find the quantity of cement at 50 kg per bag and sand gravel using Class A mixture. So for its solution, by linear method, we'll find the total length of the 8 columns. So 8 columns multiplied by the height, which is 5 meter, is equals to 40 meters. And in number 2, next is we'll refer to table 1 to 4, which is the quantity of cement, sand, and gravel for post, beam, and girder per meter length. So we'll solve along the 0.4 meter width of column by 0.6 meter length column size under Class A measure of 50 kg per bag cement. So let's solve for cement, wherein we'll just multiply 40 by 1.680, which equals to 67.2 bags. For sand, 40 multiplied by 0.120 is equals to 4.8 cubic meters. And for gravel, 40 multiplied by 0.240 is equals to 9.6 cubic meters.